Alright, non-resident training course, August 1994. Equipment operator, basic Navedtra 14081. Chapter 12, cranes and attachments. Alright, cranes. Cranes attachments are essential to supporting naval construction operation, lifting the heavy objects, loading, unloading construction materials, excavating earthworks, lowering extra piles, extraction piles. Typical tasks accomplished with the use of the cranes and attachment. Crane attachments proceed as complex setting characteristic, proper, effective, efficient operations. Crane attachments require knowledge and skill. Any other part of the construction equipment will operate. You must always be exceptionally safe and conscious when working on around crane operations any type. The chapter covered the characteristic basic operation of cranes attachments. By reading the operator's manual attending crane school, you obtain the detailed information about the crane operations. Cranes are classified weight handling equipment and are designed primarily to perform weightlifting excavation operations under various conditions to make efficient use of the cranes. You must know capabilities and limitations. Cranes have involved many design, safety, and needs for the construction and industrial operation characteristics. All cranes are basically the same. The superstructure is the same. The all makes the model of the mobile cranes. The carrier mounted on one of the three crawler, truck, and wheels. Crawler-mounted Crawler-mounted crane is categorized under 42.00000 U.S. number registration series, with the crawler-mounted slower than less mobile than the truck-mounted crane. However, the crawler-mounted crane provides stable pace for the operation for the revolving superstructure. The travel unit of the crawler crane is shown in Figure 12.2. The travel unit includes the base. Travel gears, clutches, travel brakes, braces, sprockets, roller chains, crawler treads. The revolving superstructure rotates on the turntable. Alright, shows the revolving superstructure, collar mounted, truck mounting, wheel mounting, crane carrier mountings. Chapter 12, Figure 12.2 shows the crane crawling travel unit, rotating your roller center pin, travel base casting, crawler chain, sprocket, track, erecting chain, crane crawler 12 foot to 8 3/4 long, crawler drive socket, truck frame, axles, H-beam, bull wheel, supporting rollers. 12.3 shows the turntable assembly. 12.4 with the crane radius measurement. The primary advantage of the crawler crane over the truck mounted crane is that they are suited for the continuous with the remote areas not readily accessible for the truck mounted crane because of the terrain conditions. All crane has steering with a positive traction permits the crawler crane to travel the turn, cutting up the work area of the roadway. The side of the crawler tray is spread with the wave of the crane with a large area. The feature given the crawler crane low grounding pressure 5 to 12 psi, giving the crane versatility need for the travel over the soft terrain. The crawler crane's the climb grade is the maximum grade capability of 30% on firm and dry material. The turning radius for the crawler crane is the length of the tracks, which is the 1/2 to 2 miles an hour. Because of the travel slower speed is not productive for the travel more than 1 mile with additional traveling crane longer than distance and one time and extra wear to the track. The travel distance exceeds 1 mile. Transport the crawler or tractor trailer. Consult operating manual with the detailed information required with the track travel for more than 1 mile. Steering with the crawler train is performed by the engaging steering lever in the direction you want a crane turn. Some models with the crawler cranes have a swing travel jaw clutch and is controlled by one lever. Alright, crawler mounted crane quadrants for operation. Other side, over the drive-in, and quadrant operations over the idler end. Alright, the provide power either with the swing of the crane, travel the crane with the swing travel jaw clutch that required for the operation and gave the button and push lever for the swing of the on-travel operation. Other models that have separate steering and the swing lever, allowing both the functions to operate at the same. Use the caution when traveling with a crawl crane on around the slope. Some of the older type of the crawl cranes do not have the travel brakes or power, but could be disengaged with the crawler into the free wheel. On the job maneuvering with the easy with the because of the sand turning, a small turning radius for the crawler train. Additional crawl crane in your crawler train. Crane does not require use of outriggers for stability, so requires less room with the setting up than one smaller model of the crawl crane. The track can extend with the outward, providing with the crane with the more stable with the crawl crane models with which the crawler track can extend with the later 85% of the minimum weight with the cause of the crane. The tip of the specified radius of the basic boom and the crawl models do not have. Extendable tracks rated at 75%. Crane radius measurement, the measure for the center rotation of the center of the hook after the boom deflects forward where under, shown in Figure 12.4. Depending on the make of the model, most crawlers have in 360 degrees working area. The working area is divided into operating areas. The quadrant of the operation capacity based on the quadrant is the overside with the overside drive-in or the over idler with a crawl mounted crane. Figure 12.5. Capacity of the crane may change. Rotating load with one quadrant to another. The information is provided with the crane load chart. Yeah, truck-mounted crane. The truck-mounted crane, figure 12.6, consists of the truck carrier that has the upper revolving unit. Is categorized in 820000 USN number registration. Series of truck carrier can travel from distant job sites in 20 to 35 miles an hour. 12.6 truck mounted crane. Boom, cradle, cabin, controls, counterweight, outriggers, hydraulic float, gantry, boom stops, boom hoist, revving, boom pennants, boom section, boom butt section, boom tip section, tip sheaves, and hooking block. Truck cranes have a higher ground pressure ranging from 70 to 100 psi due to the pneumatic tires on the machine travel on firmly dry surface of the truck carriers will climb a 40% grade depending on the design of the carrier. The turning radius can change from 50 over 90 feet. High turning radius limited movement early before any crane travel to the job site. The crane crew with the supervisor visually reviews the plan, travel the route to determine low wires, low overpass, narrow bridges, and other unsafe obstacles exist. The absolute limit approach power lines. Figure 12.7 is the following: 0 to 125 volts at 10 feet, 125 volts to 250 volts at 15 feet, over 250 volts at 25 feet. Any of the traveling with a crane stay with a minimum of 4 feet from the electrical power sources. When traveling with a truck-mounted crane equipped with a lattice boom, do not reset the boom on the cradle. With the lower cords of the boom can be dented if the boom bounces while traveling. Position the boom 2 to 4 inches above the cradle. Truck and wheel-mounted cranes are rated at 85% minimum weight that cover the crane. Tip the specified radius with the basic boom of the truck carrier is equipped with outriggers that provide with more stability for the crane. Therefore, when you are making crane lift, the outriggers should always be either outlined with a com second with a com third com, but a com and Navy Construction Force base instructions 11-200-01 Navy Mobile Construction. 11-12-7 shows limited approaching of the power lines. 125 volts to 10 feet, 125 volts to 200 feet, 250 volts 15 feet or more, and 20 feet over 250 volts of truck-mounted crane quadrants, quadrant over of the operator, over the overside, over the rear, over the other side, over the overside. Battalion equipment management rated free flow for the pick carry operations when only performed according to Navy FAC PL37 during the crane and certification in case of emergency as directed by crane certifying officer. Depending on the make of the model, most of the cranes over the 270-degree working area, such trains are mounted on the trains with equipped with optional outriggers that provide with a 360-degree working area. Quadrant operation truck mounted crones over the grounds on the overside, over the rear, over the front, equipped with the front rigger on 12-8. Figure 12.9 shows wheel mounted cranes. Note the capacity of the crane may change with the rotating of the load of one quadrant to another. The information provided with the crane loader chart. The wheel-mounted cranes. Wheel-mounted crane ranges various sizes have capacity of 5 to 35 tons or larger. Figure 12.9 with the wheel-mounted crane shown. Figure 12.9 hydraulically operated four-wheel drive, four-wheel steer, pneumatically tired engine-powered diesel. Superstructure consists of a telescoping boom, signal acting hydraulic lift cylinders, hydraulic operated with the hoist room and the hook block attachment. The wheel-mounted crane of the ground bearing pressure of 35 psi can travel at a speed ranging from 2 to 30 miles an hour. Can travel in 30-foot radius with a two-wheel steering, and 70-foot radius with 17-foot radius with a four-wheel steering. Can travel up to a firm dry 40% grade. The wheel-mounted crane is a mobile and flexible crane that can be driven on and off roads over the rough terrain. As best suited for the lift and around shopping, supporting fabrication projects. Call for many varied mobile lifts within small working areas. Depending on the make of the model, most of the wheel cranes have 360 grain work area. Quadrants operation wheel-mounted cranes are over the side, over the rear, and over the front. Figure 12.10. Remember that the capacity of the crane. Figure 12 mounted quadrant carrying quadrant over the rear, over the side, over the front, and over the side. Remember this, okay. Changing rotation and load of the quadrant and other information is provided with the crane loading chart. The lattice boom crane. The major components of the lattice boom crane are shown figure 12.11. Inspecting each of these components part of the operation pre-start inspection list. The lattice boom supports working load into the most common the boom that the Navy Construction Force is used all types of the most of the make of the cranes mounted at the boom, the butting on the revolving superstructure for the basic boom, which consists of the boom butt, boom tip, and the length of the increased and the adding of the boom extension boom sections. The lattice boom section are made with lightweight, thin wall, high stream, angular, old alloy, tubular, angle steel, and or designed to take compression loads. Most common boom is tubular terminal of the last boom section shown in figure 12.12. Alright, manufacturers have a zero tolerance on rust, bent lattice, and cords, crack welds, or other problems that affect the strength of the lattice boom. This zero tolerance requires crane crews to use extreme care when handling used unsection forklifts during unused sections away from the traffic areas, transporting, securing sections with the tractor trailers, and preventing equipment obstacles running into the boom while mounted on the crane during transportation, forming operation when parked. As outlined in the Management Manual of Weight Handling Equipment Maintenance Certification, Navy Fact PO307, all the lattice boom cranes or structural damage to main cords of the boom must be immediately removed from service when main cords, tubular boom section is damaged in any manner. Slight dents they are severely weakened, have failed to load significantly below the capacity allowed in outline 11.200.1. Structural repairs will not be made with the written approval of the COMSAT, 3rd, and Navy construction-based equipment offices. Alright, figure on the 1211 shows the last boom crane. It shows the bottom of the cradle, front end, the counterweight, outer rigger box, rear end for jack flow, outrigger jack, operator's cab, butt base and boom of the foot section, back hitch, gantry frame, inner base and bridle harness, boom stops, equal bridge and outer bail and floating harnesses, boom pendant tip section, boom header, tip shields, auxiliary whip line, headache ball, lattice boom inserting section, main hoist, and main hook blocking. Alright, 1212, lattice boom terminology. Lattice members, lattice or lacing, main cord, diagonal pin connection log, square frame, and at each end of the boom insert, the commonly referred to as the picture frame. Are removed from service when the main cords of the tubular boom section are damaged. We read that. In the Navy construction portion section normally comes at 10 to 20 foot lengths, with adding several sections of a different length to check the operator's manual for the boom setting configuration. And information is not in the operator's manual rule of thumb that is used when mixing short boom sections with the long sections. Install shorter sections closer to the boom butt. For example, the use of the 2 foot 10 sections and 1 foot, 2 20-foot sections. Install the 2 foot 10 checks close to the butt boom, and booms sections are bolted in plate and flange connection. Figure 12A, view A, pin and clevis connection. 12B, view B, and the most common in pin clevis. Alright, all booms and sections of the come with the crane will have the attachment identification number attached to the assignment of the boom section of the specific crane. Show the view A is the bolt connection, view B is the pin connection, the boom section connections. Alright, your boom angle indicators. Boom angle indicator normally mounted on the boom butt, visually readable with the operator on most models of the Navy construction force. The boom angle indicator is a metal with a plate with the degree numbers of 0 to 90 degrees, fairly swinging. The arm reacts to the boom angle changes. Figure 12.4. Numbers and arms should remain clean and visually readable at all times. Capacities are listed on the crane load charts, also based on the vary of the boom angle of the crane. A hydraulic crane to the boom angle is the angle between the bottom of the butt and the horizontal, while the boom is under load. With the figure 12A, view A on the boom angle lattice boom of the crane is the angle between the center line of the boom from the bottom boom butt pins to the bottom tip sheave. Horizontal while the boom is under loaded. Figure 12.5B, 12.15B. Check accuracy of the boom angle indicator with the place of 3 foot builders level on the center boom section. Raise the lower end boom until the level indicates the boom is level in figure 12.16. At this point, the boom angle indicator. Figure 12.15 shows the boom angle configuration. Boom angle on telescope boom crane, lattice boom crane. Show the boom angle. Alright, figure 12.16, check accuracy of the boom indicator, shows the level on the boom. Check the accuracy of the boom angle indicator using a 3 foot level. Alright, should you show the boom in 0 degrees, adjust the read 0 degrees. With the boom angle indicator, quick reference to the operator know what the angle of the boom is at. However, do not rely on the boom angle indicator radius accuracy, especially with the lift exceeds 75% of the rated capacity. Use the radius measurement to determine the capacity of the crane for a loaded charge to avoid any possibility of error. Sheaves are located within the hook of the block boom tip from the boom bridge, gantry, and boom mast. Sheaves rotate on either boom bearings or bushings are installed basically anywhere on the rope and must be turned or bent. Alright, your boom pendants. Pendant line with a fixed length with a wire rope forming part of the boom suspension system, each with a section of the boom to the boom pendants. The both pendant must stay in the section with the boom when they came. When storing boom sections, secure 2 pennants on the boom section with a wire rope in. If the pennant is bad, both pennants must be replaced. If only one, replace one bad pennant, the newly replaced pennant could often be different length with different in manufacture. The difference will cover the uneven pull with the twist of the boom, which is put under load strain. Or your jib extension. Figure 12 to 17 show the type of the tip of the jib extension with the jib extension from the boom cable to being mounted on either hydraulic lattice boom. The jib is equipped with our own 4 stay pendant lines. The jib tip with the jib mast. The jib mast is connected with the boom tip. The jib mast backstay pendant is normally manually adjusted with the change of the angle of the jib. Most crane with the function with the jib, they increase the lift, with the height, with the aid, with the increase the loading radius. The operator's manual will have the instructions on how to install the jib extension. You must remember if the lifts are made with the main hook block of the weight of the jib, the assembly will reduce the lifting of the capacity of the crane. Therefore, you must deduct the effective weight of the jib assembly with the gross capacity of the crane. Alright, figure 12-17 shows the jib boom extension mounted on the hydraulic boom. Boom extension marking main hook with a hook block of the main hoist, jib line, whip line, main hoist, main sheave, main boom, tip sheave, main boom, jib trolley, block, lattice extension, removal of the boom extension, jib back, say, boom extension, tip of the head sheaf, the jib mast, cancer, jib, forestay pendant, A-frame, jib, wheel line, jib line, auxiliary hoist line, jib hook, and headache ball. Alright, 12-18 shows your gantry train, a boom stop, the boom brittle, boom hoist revving, gantry book, boom hoist revving. Alright, boom hoist lines are reeved in the higher of the gantry, provided with the angle between the boom pennant line of the boom, reduce the compression force placed on during the lifting operation. On some of the model cranes with the gantry, it's adjustable, allowing it to be lowered, and so the crane can be traveled under the wires and bridges. Warning, refer to the operator's manual for the instruction on how to raise and lower the gantry. The trial, iron error, the method of lowering and raising the gantry can cause serious injury or death. Note, raising the boom while the gantry is lowered, position, lever the angle between the pendant lines and boom with the places unseen with the compression stress of the boom. Therefore, always raise the gantry before raising the boom or lifting the load. Boom mast. The model for the cranes equipped with the boom mast instead of the gantry. The boom mast sometimes can live. Called live mast structural frame hinge with the near the bottom of the boom butt. Figure 12-19. 12-19 showing the boom mast, boom heaving, and boom stop. The tip of the boom mast support with the boom hoist, late sheave of the boom pendant line with the boom mast may work with the gantry and creep the angle between the boom pendants and boom, decreasing the compression force placed on the boom. The brittle assembly is part of the boom suspension system and sometimes called the floating harness. The brittle assembly may be connected with the boom, the mast, and floating harness for the crane equipped with the gantry. The brittle assembly is connection point with the boom pendant with lines is also assembly of the sheave, then puts the boom hoist wire and rope reeves through. Boom stops are designed to prevent boom from going over the backwards and load of the line brakes. If this will not stop the boom if the operator forgets to disengage the boom hoist control lever. However, some of the models of the cranes are equipped with the boom upper limited switch that prevents the operator from raising the boom past a preset boom angle. This also prevents the operator from raising the boom, and the boom stops when the most of the cranes are equipped with the upper limited switch, also called bypass switch that allows the operator to raise the boom mast with the preset boom angle. The two types of the boom stops are shown in figure 12-18 and 12-19. Alright, house assembly. The house assembly revolving structure set up at the top of the carrier of the figure 12-20, and it provides the mount with a hoist mechanism, the engine, sometimes called the machinery deck. This operator cap's counterweight attached to the home assembly. Operator's cab. The control levers of the lattice boom crane are located with the operator's cab. Their control levers are shown in figure 12-21 are typical most for cranes. Typical crane controls are as follows. The swing lever, when pulled towards you, rotates the house of the assembly in one direction. When pushed in the house assembly, rotates in another direction. Figure 20 shows the house assembly, operator's cab, engine, counterweight. Figure 21 shows the lattice boom crane control levers, left brake drum, right brake drum, boom hoist control, master clutch, swing control, left drum lever, right drum lever. The left drum brake pedal is used to hold the load placed on the hoist line when the hook locked in, prevents the hook blocking the wire rope from unwinding with the hoist drum. Figure 12-22 shows the typical hoist brake assembly. Figure 22 shows the hoist brake assembly brakes. The main drum lever engages the power of the race in the same level as supporting lower the loads of the base on the main hoist drum. The master clutch engine with the power from the power source of the hoist swinging the mechanism. The secondary drum lever engages the power of the raise in the same level as supporting lower the loads in place with the secondary hoist drum. The sixth of the right drum brattle makes use and hold the lower loads placed in the hoist line when you locked into prevents hook, block, and wire rope from unwinding at the hoist of the drum. 7. When the boom hoist is lever allows the raising and lowering of the boom. Hoisting mechanism. The hoisting mechanism provides the mechanical power to lift the lower drums. The lower loads hoisting mechanism is usually only 2 hoist drums that are mounted side by side on one shaft in tandem. Separate clutch and brake pedal, brake controls to each hoist. The control levers operating the clutch of the brakes are normally powered to assist with the hydraulics air pressure lifting operation requires use of 1 drum, whereas clamshell, drag line, and pile driving operates require use of 2. Engine. The engine provides power in the hoisting mechanism through the gearbox or in some cases the drive chain reduction. Most lattice booms, cranes, engine mounted in the crane housing. Counterweight. The counterweight on the rear of the crane house creates additional stability. Lifting loads the counterweight rotates the hoist and swings. Most counterweights are removable to reduce overweight over the crane from transporting. Part of your pre-starting inspection is to check the counterweighting mounting. Last boom breakdown. Bridge assembly plays an important role of changing the length of the boom and forget to disconnect the boom pendants line with the boom tip. If not connecting the bridge assembly pendant lines begin behind the boom section you plan to remove and install. You drive the bottom pins and the top pins will act as a hinge. Boom will fall as shown in figure 12, 30, 23. If you make this mistake, a crew member is under the boom. The tragedy could result as shown in figure 12, 24. Alright, 1224, never work under the crane boom. Warning, never work under the crane boom. Because so many accidents occurred with the while personnel changing the booms, some manufacturers have made one-way connection pin that only can be installed from inside. That requires the pin to be removed only from the outside, keeping the personnel from getting underneath the boom. Figure 1225. The common practice in Navy construction forces is installing the pins inside out of the preventing personnel with maneuvering inside of the boom and to drive out of the pins. Several methods used to break down the life of the boom to add or take out sections. If the boom section is a bolt connected, to use most tonnage for support under each section. Figure 1225 shows driving pins from the outside in. Blocking under the joint at both sides. Driver never under a crane or outside safety or inside suicide. Most common boom connection is in pins to break down the pin connected booms. Make sure the hook is in the front of the pin removed. Lower the pins removed. Wrong boom will fail. Incorrect way to disconnect the last boom. Alright, I have gloves, hard hat, safety glasses, goggles, and safety shoes, all hands and sledgehammers and pilers and crowbars, marlin spikes, and extra cotter pins and dunnage. Warning, always wear gloves when handling wire rope. When breaking down the last boom, take the opportunity to provide the inspection item thoroughly as the connecting pins, cotter keys, inside connecting lugs, or wear rust or surface cracks. A common method used to break down a pin-connected basic boom is to add sections as it follows. Set outriggers swim the upper revolving unit over the rear side depending on the make and the model of the crane. Lower the hook block and to the ground and provide the slack in the hoist line. Next lower the boom and set the boom tip sheaves on the piece of dunnage. Engage the boom hoist control lever to lower the bridle assembly. Boom and hoist may slacken the pendant lines. To prevent the pendant from lines falling out of the ground, using the wire rope to secure the pendant lines to the boom. Remove the cotter pin to drive out the main pins with the bridle assembly connection to pendant lines. Position of the bridle assembly top of the boom butt figure 26 with view A that has dome with having the operating engine with engage the boost hoist control lever to tighten the boom hoist lines until the bridle is positioned on the top of the boom butt. Then align with the pinholes manually position bridle assembly using the crowbar with the pins have attached to the pendant line and connections are. Alright, 1226 boom hoist assembly connected to the boom butt. Show the boom mast connection. Show the boom mast for the boom hoist rearing the boom on the tip on the blocking. Lower pins may be removed from here. Center line boom straight. Pendant connected behind pins being removed and pendant must be taut. Alright, your gauntry train. The gauntry boom hoist revving and boom bridle connected to the boom butt and boom butt. Normally, the pins used to connect with the bridle assembly of the boom butt. The crane is equipped with the boom with the blast for the boom mast. Normally, a short section of the pin is connection with the boom butt pin and holds view 26A or 26B. Note, visual check for the boom hoist drum, then check for the boom hoist wire rope does not loosen the cross wire with the hoist drum. The result in crushing, kinking the wire rope. Tighten the boom hoist line to support the weight of the boom, but not so tight that the boom tip will lift it off the dunge. Remove the cotter pins of the boom with the connection pin to drive out of the lower boom connection pins. After the lower pin is removed, engage the boom hoist control lever lower bridge assembly or mass loom, allowing the boom to separate at the boom, and then by hinging the top pins and hence lower the boom on the piece of the dunge. Remove the top connection pins. Once removed, engage the boom hoist to ensure that separate boom connection lugs. When the boom breakdown is performed over the rest of the rear of the crane, you separate the boom with the bracing with the outriggers enough to move the forward from the travel unit of the two by releasing the brakes on the hoist line, slacken the hoist wires if the travel units move the forward to allow space to add sections. When breaking down a boom that's performed over the side of the crane, you separate the boom, releasing the brakes of the hoist line to slack the hoist wire rope. And 2, use the forklift to pick up the boom tip and carefully maneuver it enough to provide adequate space to insert the boom sections. The method of adding the boom section is as follows. Have the forklift in line with the boom section with the boom butt. Reverse the crane until the boom butt top of the pin will cover next to the lug as are connected with the top of the pin connection lug to the boom section. The boom breakdown performed over the side of requires the forklift to maneuver the boom section until the pins are aligned. Once the top lugs are aligned, the drive of the bottom boom pit connection pegs on the top lugs and inside out and insert the cotter pins. Alright, 4. Engage the boom hoist control lever to drive the boom butt. Allow the top of the pins to perform the hinge of the draws on the bottom of the connection lug together. Once the boom butts are aligned, drive the boom connection pin for the boom lugs from the inside and out. Insert the cotter pins. Raise the boom butt and boom section several inches clear of the ground. Reverse the crane until the top of the connection lug for the boom section aligned with the top of the connection lugs on the bottom tip. Final alignment of the lugs might require the use of the crowbar. Once the lugs are aligned, the drive of the boom and the connection rod at the top of the lugs insert the cotter pin and engage the boom hoist control lever to raise the boom section boom tip. The result of the top of the pin performing the hinge of the drawing with the bottom pin and the connection lugs together. Once the bottom lugs are aligned, drive the boom connection pin with the bottom of the lugs from the inside out. Insert the cotter pins. Reset the outrigger to produce the connection bridle assembly of the boom pin as follows. Engage the boom hoist control lever to lower the bridle assembly boom after the product of the slack and the boom hoist wire rope. The next step is to connect with the boom bridle with the sum of the boom section pennant level down with the disconnect of the bridle assembly from the boom butt with the manual maneuvering from the bridle assembly to connect with the boom bend for the boom section to produce the slack of the bridle assembly may require manually feeding of the boom hoist wire rope through the sheaves. For the cranes equipped with the boom mast, lower with the boom mast connecting the pennant lines. When the pennants are connected to the bridle, the good practice insert the pin with the inside out. With the practice allowed with the easel visual inspection with the cotter pins insert with the pennant line pins. When the boom is in the air, the next step is to connect with the boom section pennant. For the boom tip pennants, it usually requires manual labor to allow the boom section pennants to the pennant boom tip pennants. You must also have to engage the boom hoist control lever to provide slack with the boom hoist line. The pennants lines. Once the pennants are aligned, insert the pennant cotter pins and cotter pin connection pins and cotter pins. Alright, next engage the boom hoist control lever to raise the boom bridle assembly pins. Before doing this, go through and visually inspect all the boom pennant line pins with the connection cotter pins have. Secondly, someone visually watch the boom hoist drums to ensure wire rope does not cross wire and cause wire rope to crush or kink. Additionally, ensure all the boom hoist wire rope is properly running and all the sheaves and on earthing check out to engage the boom and the hoist control lever the raise for the bridle assembly and pennants until they're tight. 6. Visually check the boom suspension system before raising the boom off the ground as the boom is being raised. Visually check the revving of the boom hoist wire. Once the boom is erected, check the hoist of the wire rope revving. Must ensure the wire rope is correctly flowing through the bottom of the tip of the hook of the block sleeve, winding properly on the hoist drum. Before the crane can be operated, it is outlined with the Navy Mobile Construction Battalion equipment and Common Second and Common Third and Navy Construction Battalion Instruction 11-201. Before putting in the crane, service the crane test directed must inspect the crane, the correct installation, all components with the very prior testing, mechanical addition, adding components to the crane. Certifying officer may direct crane to be loaded, test and safe loading capacity, minimum, maximum radius. Or the telescopic boom crane. The telescopic boom cranes are typically called the hydraulic crane of the boom. They're composed of the sphere of the rectangular trapezoidal, other shape with a symmetrical cross-section segment fitting into the other large segments at the bottom of the boom is called the base of the section boom butt. The small section on the top of the boom is called the tip of the section boom tip. In between, they can be one of the more section first and second and so forth cranes. Section of the more boom for retractedly telescope the boom crane, highly maneuverable, easy to transport the job site. Telescopic boom cranes nomenclature in figure 1227. 1227 show the telescopic boom crane nomenclature. Center pin, center rotation axle, rotation counterweight, truck cab, auxiliary hoist, carrier, hydraulic outriggers, operator's cab, boom hoist, lift cylinders, main hoist, heel base and foot section, dynometer for the wave load, and actual automatically safe load indicator, power telescoping, selecting telescoping section, main boom tip ahead, auxiliary wheel line or whip line, auxiliary hook and headache ball, main hook or ball block, main hoist line, hook, and boom extension markings. Alright, section. Telescopic booms are pinned by the boom to the full-powered boom. The combination of both and pin booms means the section are pinned into the extended retracted position. A full-powered boom main section extended with a retractable hydraulic. Some models have the full-powered main boom with a within-pin boom tip of the section. Read the operator's manual for the proper operation. The type of the boom that is equipped on the crane that you are assigned to operate. A full-powered boom, the sections are extended with a retract except for the base section with the hydraulic cylinders called the extension cylinders. Cylinders are each mounted on the firewall of the boom center line. Within each section of the boom extension cylinders on both the telescopic booms have sequencing valves to allow the exterior section to extend telescope by equal marks. These cranes usually have single telescope control lever than cab. However, the crane is not equipped with the section sequence valve. The operator will have to extend each section equally. With the crane will have 2 or 3 boom telescoping control levers in the cab, each for the controlling only a single boom section. If the boom sections are extended unequally, the most fully extended section of the boom could be into uneven stress. Additional load chart will be invalidated for determining the rate of the capacity of the crane. Boost dimensions are marked off the equipments as shown in figure 1227. Make it easy for the operator to signal to make sure each section is extended equally. When a load placed in the telescopic boom, the load of the wave of the boom is called the hydraulic ram, and the boom stiffens up with a slightly curve of the load is removed the boom, and the rams return straight and become this. Do not extend the boom while it's under the load. Return the operator's manual from the boom extension information. Alright, your hoisting mechanism. The hoisting mechanism of the telescopic rim with the hydraulic-powered hoist drum. The hoist drum is mounted behind the boom within the crane house of the revolving turntable. Some of the hydraulic cranes are equipped with 2 hoist drums, one of the main hoist, and the second with the auxiliary whip line. The hoist assembly is a revolving unit with the support of the boom. Small hydraulic cranes that have the operator's cabin counterweight attached to the revolving unit. The operator's cab, the telescopic crane, when they have the hoist and swing boom, the control lever similar to the cab lattice of the boom crane. The control lever is provided with the extend to retract the boom. Hoist systems do not require the full foot control pedal with the brake hoist and control lever to return to the neutral position. The hydraulic system holds them foot place. Power source. The power of the telescopic cranes comes from the hydraulic fluid. In most cases, the main carrier engine gave the drive of the hydraulic pump. The supply of the hydraulic fluid to the hydraulic control component. The power is diverted. Hydraulic motor cylinder valve body. The operating control station. Hydraulic power provided with the positive control of all of the crane's functions. Or the counterweight on the telescopic crane provides greater stability when lifting loads. When performing the near capacity lift with a high boom, the angle of the using the telescopic crane with a 60% load with the plate for the outriggers for the load. When performing the same lift with the last boom crane with about 60% of the load and place outrigger for the close of the load. Crane attachment. Crane is a versatile piece of equipment that can be equipped with various attachments to perform a number of the different operational attachments, include a hook block and camshell and the drag line. A hook block. Crane that is rigged with a hook block is from the primary unit lifting objective loader and transferring the new place, swinging the treble, and then placing the load. Figure 20-28 show the 8-part line of the rigged hook block. The number of parts on each of the line rigged on the hook of the block is important to the figure capacity of the crane. Most crane load charts are shown with the rated capacity of the crane's different parts of the line. For example, the crane that is capable of being rigged with an 8-part line is rigged with a 6-part line. The 8-part line gives the crane greater lifting capacity. Therefore, you must check the load chart for the 6-part line to capacity to avoid overloading the crane. Alright, 1228 show the hook block. Show the 8-part line sheave, the center pin, the safety coloring marking, and the check weights, the safety latch and pin, and the hook throat. A clamshell consists of the hoist drum lagging, the clamshell bucket, tagline, wire ropes to operate the holding and closing line. Same crane model with the hoisting drum lagging. Hoist drum diameter can be changed to meet the speed and pull requirements for the clamshell operations. Once the crane is rigged with the clamshell, the crane is referred to the name of the detachment. When changing the attachment from the hook of the block of the clamshell, check the operator's manual for the correct length of the wire reeving. For example, some cranes model will require 300 to 400 feet of wire rope for the hook block operations, only 100 to 200 feet of wire rope for clamshell operations. Too much wire rope in the hoist drum during the clamshell operations will cover the wire wraps of the wire rope to loosen the hoist drum's cross from the winding, resulting in crushed wires and kinking spots in the wire rope. Very expensive to cover. The wire rope is usually no longer useful for hook block operations. Changing the length of the rope requires unreeving the hook block wire rope and reeving the correct length of the wire rope for the clamshell. This may be time-consuming effort, but it saves you from having to replace 300 to 400 feet of wire when the crane is rigged for the hook block operation. Clamshell bucket figure 12 to 29. If the two screws hinged together with the center of the counterweights. Shows the closing line, the holding line, the dead end here from the 2 to 4 to 6 part line. 4-part closing line with shackles of the tag line and bridle chain, the weight of the opening clamshell, the dead end here in the 3 to 5 part line. Alright, bolted around the hinge 2 hoist drum wire ropes and the crane rigged with the holding and closing line and control of the bucket with the example of the clamshell rigging configuration shown in figure 1230. Tag line under 1231, control of the tension of the tag line helps prevent the clamshell from twisting during operation. Like clamshell buckets, tag line will exchange most of the make of the model of the crane in the same size range. Alright, drag line component figure 1232 consists of the drag line bucket of fair-lated some of the wire rope component of the drag line drag cable, the bucket of the hoist of the dump, and the other crane rigs with the drag line crane is referred to by the name of the detachment. When you're loading the bucket of the fair lead with the figure 1233 guide for the drag cable on the hoist drum, that will hoist wire rope which is reeved through the boom point sheave and raised to lower the bucket. Warning: on some models of the cranes, you must make sure of the fair lay with the vertical position, lowering the boom to avoid bending of the cords of the boom base. When changing the attachment for the hook block of the clamshell drag or to the drag line shaft, the operator's manual length of the diameter side of the wire rope required for drag line operation pull for the force of the drag line. Figure 1230 shows the clamshell rigging configuration. Right cable drum, left drum cable, the tagline cable, tagline winder, sheave cable, guide rider, and sheave the dead end socket, the holding cable, the closing cable, right boom sheave, and left boom point sheave. Drag line, left cable, the drum, right cable, the drum, the fair lead with the drag cable, the drag chain, with the bucket 2, the drag line bucket. Dumb sheave, the bucket, dumb cable, 3-way socket, the hoist cable socket, the hoist cable, and the center boom for front sheave. 1233, drag line, fair lead. Alright, many requires a large diameter drag cable, the length of the hoist wire, but also short and normal to avoid the cross winding of the hoist drum. The drag cable pulls of the bucket from the material with the digging. The bucket is rigged with the hoist of the wire rope and the move to the point and dump point. Dump of the bucket may relieve the tension from the drag cable. Note: do not lubricate the drag cable. The drag cable is lubricated to pull the dirt. Retain the dirt which causes damage to the wire rope. Construction industry rate the drag line buckets in different types of classes. The type of classes are follows: Type 1 light duty, Type 2 medium duty, Type 3 heavy duty, Class P perforated plate, Class 3 S solid plate. Are the most common buckets used in the Navy are the Type 2 Class S bucket. The Class P buckets are available. The dragging operation figure 1234 shows the makeup of the drag bucket. Crane operation. People are crippled and killed with the numerous property damage incurred with the direct result of the crane mishaps. Most of the crane mishaps result in the operator error. The Navy Construction Force has an extensive crane safety program. Applies to a crane operated with the safety operation weight handling. Standard weight handling equipment operations are outlined in management of the weight handling equipment. Navy Fact PL37, Navy Construction Force Equipment Management Manual, Navy Pack 404, Navy Manual Construction Battalion Equipment Management Compensec from the Compensec 3rd Navy Construction Battalion Instruction 11-201, Youth Wire Rope and Sliding Rigging Hardware for the Navy Construction Force Compensec Common 3rd Navy Construction Battalion Instruction 11-200B1, 11-211, and Testing License Construction Equipment Operator Navy Pack 306. Alright, crane crew. The skills and safety standards demanded with the efficiency crane operation require only mature professionals assigned with the crane operator's rigor. The supervisor of the crane crew is normally the best crane operator available. The battalion-wide assets and assigned with the designated with the writing of the commanding officer, the equipment officer with the crane test director. The crane crew supervisors share the responsibility ensuring any person who prepares the assembly operator that works with or around cranes are well trained with the both safety operation procedure. Before you receive the license to operate with a crane operator is required to attend 40 hours of formal classroom instruction on the crane operating safety. As outlined in Navy Pack 306, for the additional operators will need to renew their license must attend the minimum. Alright, figure 1234 shows the drag line attachment. 1 is your hoist, 2 is the dump bucket, 3 is the dump rope, 4 is the upper hoist chain, 5 is the spreader bar, 6 is the anchor bracket, 7 is the arch, 8 is the lower hoist chain, and then there's the top corner, 11 is the 11 is the hitch plate assembly check, 12 is the sheet, 13 is drag chain, 14 tuning line bracket lip, and 15, 16 point adapter bottom runners that are not shown, 18 corner wear through, 19 drag rope socket and crowd foot, and 20 drag rope. Alright, 8-hour refresher training course for the crane operator. The testing crane operator is directly responsible for the responsible for the crane certifying. The crane certifying operator officer may assist with the administrator of the performance test for the crane test director. Commanding officer is normally responsible for the duty for the crane certifying officer is designated with the writing of the commanding officer. The crane certifying officer designates the writing of the crane test. Director of all crane test personnel crane licenses issued with the construction equivalent operator Navy Fac 11-2602 will indicate the make of the model capacity for the attachment of the operator is qualified to operate. Signalman is part of the crane crew with the responsibility operator to give the signal for the lifting, the swinging, and lowering of the load. The signalman should be qualified seasoned crane operator. Not only does the signalman give signals over the handling loads, but a signalman can visually observe the operator that can see the operator's cab. For example, during the lifting, signalman should make the visual check of the lifting. The loaded hook is centered over the center of the balance below, but the weight is being lifted with the crane. The boom deflection does not exceed the safe of the long load radius. All rigging gear is straight and not cause the damage to itself and lower load. During the lifting of the boom crane, check the boom system, the boom hoist revving, and ensure the proper operation. Check the hook boom and the boom tip sheath, reeving to ensure the proper operation. Check the stability of the outriggers, especially swinging the quadrant in operation another. Note on some of the crane's capacity of the crane change the swing of the rear quadrant to the overside of the quadrant. Use the tagline handle to prevent the loads from swinging and twisting. Warning, always personnel to control the load without using their hands to put with a great danger should the load fall with the sun's unexpected mishap with the signal only lift the load high enough to clear without any obstacle. Always use eye-to-eye contact with the crane operator. The crane operator depends on the signalman to lift and swing lower load safely. Signalmen also must know the load weight being lifted with the raised capacity for the crane. The basic handling signals that you with the Navy Construction Force are given in Appendix 4 of the trauma, and only one person give this signal to the operator at one time, and only one should give it a signal with an emergency stop. Our rigger, the rigger or the riggers are responsible for the operator with the properly attaching rigging gear with the load. The rigging can be extremely dangerous if not properly performed. Safety gear such as hard hats, steel-toed shoes, gloves, and any other personal safety clothing needed must be worn. Riggers and signalman must be closely work together, avoid loading disregard rigid signalman, visually check the proper rigging. If the operator cannot visually see the operator's cab, the other rigging is approved, then load can be lifted, the signal to be lifted. Note the operator has final approval of any of the life end, but it has ultimate responsibility for the crane lift and safety. The operator pulls the lever of the crane and directly responsible for the crane and load rigging, lifting, perform, must know the crane, how the operator respond under load and unload conditions, proper rigging procedure. Signal must be able to set the crane up for proper lift, keeping in mind that safety comes first and production is second. Crane operators daily inspection. Before crane is operated or transported, must be thoroughly inspected by the operator. Operators give the crane operator daily inspection sheet. The operator in Figure 1235 inspection sheet checks each item prescribed on the checklist. When the operator observes the deficiency, load bearing or load control partially safe device, major deficiency, any operating condition that would cause less or control otherwise render. The crane safe. The operator must secure the crane and notify the crane crew supervisor. I shows the lubrication, the crane operator's daily checklist. Alright, the Operator Daily Report, PM Management, Preventive Maintenance Report, Navy Fact Form 112604 with the chief of the ODCL with the performing the crane pre-start inspection. The ODCL with the term the crane crew supervisor end of each of the day with the ship of the reviewing the signaling. Signing the Navy Fact Form 112604 with the term of the dispatch outline with the Navy Fact PO37. Minimum requirement to retain the ODCL with the completed during the current month and during the previous month of operation. Alright, wire rope inspection. Part of the ODCL inspection through the inspection of all wire before using the crane. All the running rope of the continuous service must be visually inspected for crushing, kinking, or corrosion or other damage broken wire. Proper lubrication figure 1236. Other areas inspect the wire rope sockets and swage, fittings, swivels, pendants, securing hardware. I always drum that any fittings need only to be disconnected. This only assemblable when experience visual indication deemed it necessary. The exact time of the replacement of the wire rope cannot be given as many of the variables are involved. However, the shift depends upon the good judgment of evaluating wire rope. The following conditions are reason for the wire rope replacement. Running rope 6 or more broken wires randomly distributed broken and torn wires in one way, 3 broken wires in one strand in one way to replace the end. Connection with any of the broken wire adjacent to the end connection. Shows the common wired rope defects: bird cage, kinking, section through the worn section in large view with a single strand. We'll watch for the broken wires in this area. The socket must be replaced. Broken wires near fittings are established the rope condition section showing the maximum deterioration. Replace the rope if the 6 or more broken wires are in one lay, 2 or more broken wires in one strand in one lay, 2 or more broken wires in one lay standing ropes. Measurement between width and points of the strand and the top strands. Correct weight of this given the correct diameter. Incorrect, this does not give it the correct diameter. Or connection by any of the broken wires adjacent to end connection. The boom pendant wire ropes more than 2 broken wires in the lay section beyond the end of the connection. 1 broken wires at the end of the connection. Kings and cross sections. Insert kings and cross rope in the straight runs of the wire rope core force and through the outer strands. Flat section where the diameter across the flat section less than a fifth. 6 of an original diameter wire rope or measured wire rope with the wire rope calipers. Check with the wear accurately. Replace the wire rope when wearing wear 1/3 of the original diameter outside of the individual wires. Crescent wrenches to be used with expended measures to wire the rope. Or your hook block inspection. Hook block and the hook block the ODC inspection operators must inspect the hook block with the cleanliness, binding sheath of the damaged, worn sheath, worn, disturbed sheath pins, broken bolts, worn cheek weights. Or your hook is inspected due to damage except for the wear hook, safety lack, hook, swivel truss, and thorough collar, securing nuts. Hook is inspected for the damage, misleading lubrication, fitting of lubrication cracks, and gauge of the visible vent and twisted. Sheave inspection figure 1239 with the inspection for the wear, the damaged wear on the wire rope, sheave the groove and loosen the damaged sheave the yards of the worn with the bearing pin that should rotate either the bearings and bushings inspect the discoloration due. Figure 1238 hook block inspection, throat safety latch, hook yoke shell, hook inch level, trunnion sheave, side plates, sheave center pins, check weights, cheek weights, and becket. Or improper. The observable groove so that it may be clearly seen whether the contour of the gauge matches the contour of the bottom of the groove. A proper fitting sheave groove should be supported with the rope over 90 and 150 degrees of the rope circumference. Check for the proper size. Check flanges for wear and chip the craps. Check for the bearing of the wobble or lubrication and ease of rotation. Check for sheaves and grooves and for wear. A sheave deadly corrugated the rope prints or condition that could seriously damage the wire rope. Sheave must be replaced. Alright, 1240, wedge socket. Standing bitter end with the socket pin with the cover pins and wedge. Excessive heat, metal particles chipped in the display for the metal and broken, distorted bearing retainer and seals adequate lubrication tight bearing caps. Alright, your wire rope end connection. Wire rope end connection must be specified by the manufacturer. Most common type of the connection for the Navy construction force wedge socket, figure 1240. Wedge sockets develop 70% of the back breaking strength of the wire due to the crushing action with the wedge swage socket, the cable socket, the zinc spelter socket, the wire rope connections, all of them provide 100% breaking strength of the wire rope when properly made. Extra caution when wedging the socket connection you to make the rated capacity lift of the wedge socket, particularly subject to wear, faulty component fit with the damage frequently chains out within are hardly vulnerable inadvertent wedge or release to assemble the two block situation. Two block hose hoisting hook block sheathed against the book sheaves. Wedge sockets must be installed and specified with the following procedure. Cut and remove any section wire rope you with the socket of the was subject to sharp and bending crushing before resocketing. 2. Install the wedge socket carefully so that the wire rope and the carry with the loading of the directly assigned with the eye of the socket clevis spin with this to ensure the load is directed with the place of the socket upright with the brink of the rope in the large area with the easy to handle loop with the extent of the depth and then the wire rope of the socket with the distance at least one rope blade. Insert with the wedge of the socket, printing the rope adjusting around the wedge. As safety precaution, install the wire rope clip on the dead end wire rope that comes out of the wedge socket. Figure 1241. Measure the distance from the base of the wedge socket with the clamp, measuring it. Use the guide check the wire rope, slipping it into the wedge socket. Do not test the wire rope clipped into the dead end and live end of the wire rope that comes out of. Loop back shows no clip. Special clip method, extra piece of the same size rope is clipped to the main rope. Wedging socket clip method. Wrong. The clip transfer with the load to the dead end of the rope. No. The clip nuts will be rubbed with the live rope. Correct. Wedge socket improper the proper wire clip and replacement shown figure 1242. Ensure the socket and support carefully take the strain on the live side of the rope to ensure the proper initial setting of the wedge. Increase the longitudinal gravity rapidly until the wedge is fully seated. Avoid sudden shock loads. Our crane lifting checklist, figure 1243, outlining COM second and COM third and Navy construction boards, instruction 11201, must be filled out with a crane supervisor, the crane test director before the crane proceeds to any of the project by any crane lift. After the crane lift checks are complete, the crane crew supervisor brief the operator rigorous safety about lifting the travel conditions. Crane stability, setting up the crane lift, the most critical portion of the crane operation, most cause of the crane mishaps as follows. Crane lift checklist, location of the lift, supervisor responsible lift, crane operator, riggers, helpers, lifters, lift description, lift the weight of the item to be lift was weight estimated, yes. Can weight be verified, yes or no? Crane assisted lifting, USN capacity number, travel route, unsafe obstacles, yes or no? Travel permits obtained if required. Travel. I have operators been brief sequence to follow during lift. Has crane been set up, inspected stability? Has the crane operating area been inspected? Have the sidings or the other hardware been inspected? Alright, shows the many crane attachments cover the poor blocking under floats. Show the using side blocking under the all floatings. Alright, figure 1245, crane capacity load with the crane out level. Crane capacity out level, the crane's out of level by 1 degree, 2 degree, and 3 degree. Boom length, short boom, medium radius 10 to 20, 30. Short boom, maximum radius 8, 15, 20. Long boom, minimum radius 30, 41, 50. Long boom, maximum radius 5, 19, 15. Failure to block the crib and under the outside rigger as well when poor conditions, ground conditions cannot support the total of the weight of the crane load. Proper and improper the cribbing is shown figure 1244. Extend the outriggers fully. You put the following manufacturing instruction. Failure, no overhead obstruction such as overpass and power lines. Failure level the crane. Leveling the crane cannot be overemphasized. Crane must be set up as per manufacturing instruction with the outriggers fully. Extend the crane. Leveling crane capacity allow for the crane with the level only a few degrees. Figure 1245. Most cranes have a level mounted without them, but levels are not always accurate. You put the 3-foot builder left and level to check the level of the crane over the rear of the overside 1246. Low capacity. The rated capacity for the mobile cranes are based on both strength and stability. Manufacturer crane normally denote the load of the chart shaded area of the bold line across the chart dividing and limiting crane capacity based on the strength and stability of the crane. It's extremely important to know the difference for one of the case of the structural component for the crane will break in, and other case of the crane will tip over. Additionally, the following factors must be recognized with the capacity adjusting accordingly. Do not use able to do it during lifting the capacity load chart. Install with the crane manufacturer load chart is securely attached to the operator's cab. The number of the parts line with the hoist and size, the type of the wire of the rope, various crane loads, and the length of the boom angle, the boom pendant angle, which is the telescope, the following gantry is down with the angle decreases and thrust increases. Figure 1124, 6 leveling procedure. Use the builder's level. Check the level over the side. Builder's level. Swing. Check the level over the rear. Alright, gantry, and or living the mast high position, quadrant operation with the overside and over the rear capacities. Load chart, rating chart. A typical load rating chart shown in figure 1247. The typical capacity for the crane using load with the chart. The operator must know the length of the boom, long, radius, boom angle. The lift is to be performed over the side, over the rear. When performing lift, you with the boom with the angle of the indicator. Indication of the angle noted on the load chart. The next lower boom angle noted on the load chart for the determine the capacity of the crane. For example, use the load charts figure 1247 with the crane with the ridge of the 60-foot boom with the boom angle with the indicator of the boom angle of 56 degrees. 56-degree boom angle load capacity is noted on the load chart. You must know the lower noted boom and the angle 53 degrees and for the determined capacity of the crane. No, do not rely on the boom angle indicator with the radius capacity accuracy with lifted 75% radius capacity. Measure the radius available. Avoid the possibility of error when using radius measurements not noted on the loading chart. The next longest radius measurement noted on the load chart to determine the capacity of the crane. For example, using the load chart figure 1247, the rig with a 50-foot boom radius measures 32 feet. The 30-foot radius measurement is not loaded on the load chart, so you must use the next longest radius measurement of 35 feet noted on the load chart to determine the capacity of the crane. The number of part lines reeved on the main, the hoist, the block, and the effect of the capacity of the crane. If the crane is capable of being reeved with an 8-part line, the reeving is changed to a 6-part line. The capacity of the crane changes. A newer model for the capacity of the different part of the line configuration is noted on the load charts. Only older models you must refer to the manufacturer's manual. Our load chart provides capacity of the crane with the outriggers without the riggers. Outriggers 17. Outriggers fully extend with the weight of the crane is off of the suspension system. Tires are off of the ground in situation arise where the outriggers cannot be fully extended, but they must be with outriggers loaded with the capacity rating to note the loaded capacity chain with the swing when swinging each quadrant operation such as frame over the rear of the overside. Safety lifting. For the following factors, basic guidelines for performing safely daily crane operation. Determine the wheel weight to be lifted and the crane to be required to make the lift safely. Travel the proposed route with the crane will and follow the inform of the projection site for complete with the crane level checklist. Obtain the travel permits if required. Brief the operator's riggers on specify the limit of the travel conditions. Inspect the crane area to set up with the stability of the operating area. Full extend the outriggers used with them according with the manufacturer instructions. Check with the crane for the levelness. Inspect the ridging hardware and select the proper slinging line with sufficient capacity rating. 10. Center sling with the base of the bowl with a hook with a void hook pin point loading. Ensure the hook block is always placed over the center load and eliminate the shock loading of sling cranes resulting from the load shifting when the lift is made. Make ample safety allowance for the unknown factors. Staying clear of the do not walk on suspended loads. Boom deflection. Claim rooms have deflection with load is lifted on the ground. The boom will deflect, causing the radius to increase. They increase the radius for the overloading of the crane. Uncontrolled swing load can help the radius increase. Clean the operation area with the water coolers, except for fuel grease, solid soda can with the other necessary items should keep to the outside of the operating area of the crane. Water coolers must be kept off the crane to prevent. Maximum load crane surface boom and the length of the feet, length of the radius and feet, boom and the angle of the reach, boom and the point pin of the height. Without riggers, side overside over rear. Without riggers, overside 8 foot and 9 foot wide, and over rear 9 foot or 9 foot wide. Our people congregated with around the crane when in the operation. Note safety lifting of the paramount projection completion must not be interfered with the safety of the crane operation. I'm going to check it out. I'm doing pause and check how many pages the left is. We're going to cut the tape here. And remember, it's 3:32.